CoFunctions. So the underlying definition of cofunction is when we can express one function, say function f, in terms of function g for a different argument, for the different value. So our objective here will be to express sine function in terms of cosine, cosine in terms of sine, tangent in terms of cotangent. So the diagram here, right on the screen, you see a blue triangle, OAP, and the red triangle, OA prime, P prime. The blue triangle was rotated by the origin by 90 degrees. So this is why that angle marked in black represents 90 degrees plus angle alpha. So this is 90 degrees plus angle alpha. So the entire triangle was rotated by 90 degrees around that fixed point O to the left, and corresponding sides are of equal value. So this distance is equal to that one over here. The vertical distance here is equal to the horizontal in value. So the measurement of this side is equal to the measurement of that side. So angle alpha, just to be clear on that, is defined between x-axis and the rotating arm r. So angle 90 plus alpha also is found between the positive part of x-axis all the way up to the r side. From the previous video, you would most likely remember, if not, I'm inviting you to review that, the sine ratio for an angle greater than 90 degrees was expressed in terms of the related angle theta. So we can say sine of that 90 plus alpha definitely is equal to sine of angle theta. But there's no benefit to that statement because we have now one unknown on that side, another unknown on the opposite side, so there's no real benefits to this equation. However, sine of angle theta, that ratio, is represented by the ratio of the following sides: y divided by r. So sine theta is equal to y over r. So for that red triangle, the ratio of y over r would represent, in terms of angle alpha, would represent cosine of angle alpha. So now we can replace the right hand side with cosine alpha. Cos alpha. So this is our conclusion, that sine of one angle is equal to cosine of the other angle. Whether we're using degree units or radians, same thing. We can rewrite this formula as sine pi over 2 plus alpha is equal to cosine alpha. So this is just a different unit. When you will watch the video on the addition formula, sine of A plus B, you will see that this expands to the following: sine A cos B plus sine B cos A. So let's apply this formula for our identity here, that sine 90 plus alpha is equal to cosine alpha. So sine 90 plus alpha. So now, by analogy, you can say A represents 90 degrees, angle B represents angle alpha. So in the expansion, you will see sine 90 degrees cos alpha plus sine alpha cos 90 degrees. Oops. So simplifying that, sine 90, if you recall, this is the ratio where y is equal to r. So this is just 1 times cosine alpha plus cosine 90 is 0. So this is just add 0. So therefore, in the end, you will have that following statement, sine 90 plus alpha is equal to cosine alpha. But this will come a little bit later. So for now, just know that for sine 90 plus alpha, the cofunction that is equivalent in value is cosine alpha. Now, cosine 90 degrees plus alpha. So once again, from a previous video, 90 plus alpha represents an angle which is greater than 90. So cosine ratio in the second quadrant is equivalent to the ratio negative x over r. Negative x over r, which is, in other words, cosine of angle theta. But to say that cos 90 plus alpha is equal to cosine theta is not really good, because we have two variables. We want to express cos 90 plus alpha in terms of angle alpha. So let us go back to this diagram and examine closely where is negative x is also here, and negative x to r, negative x to r with respect to angle alpha does represent sine ratio. So now we can say that cosine 90 plus alpha, instead of being equal to cosine theta, negative cosine theta I should say, this is now equal to negative sine ratio of angle alpha. And this is what we wanted to achieve, that identity. When you recall the identity, addition identity for cosine, so cosine A plus B, this is equivalent to cos A cos B minus sine A sine B. This is further explored in the video on addition formula. So now, A is represented by 90 degrees, angle B by angle alpha. So replace that with 90 plus alpha, and then you'll see that you have cos 90 cos alpha minus sine 90 sine alpha. So cos 90 degrees has a value of 0. So this is 0 minus sine alpha. Sine of 90 degree has a value of 1 times 1. So this is y. This is equal to negative sine alpha. Okay, so this identity makes sense, and it does really, if you recall the videos on trig ratios with values greater than 90, cosine in second quadrant must have a negative value. So this is why cosine of 90 plus alpha is equal to negative sine alpha. Now the tangent ratio for the angle 90 plus alpha. So by analogy, this is the angle that is greater than 90, so tangent 90 plus alpha would be represented by the ratio y over negative x, because the related triangle with angle theta would be the reason for that. But again, we can't really conclude that tangent 90 plus alpha is equal to tangent theta and leave it like that, because it's not really beneficial. So let us take a look at the right angle triangle in red and make note what is the ratio y over negative x with respect to angle alpha. So y over negative x represent cotangent of angle alpha. So we need to replace the right hand side with cotangent alpha. So therefore tangent 90 plus alpha is equal to cotangent alpha. So this concludes our session on cofunctions for the addition formula. The next video will show you how to find cofunction using the subtraction formula. Thank you very much for watching and see you next time.